Hi, this is Kevin, and I'd like to welcome you to my tutorial demo on Chapter 2 in the Java course. And this first demo is going to be one in which we print out a sequence of numbers. And I want to pick a fairly easy sequence so that we're not concentrating on the math. And so I'm going to do the powers of 2, starting with the 2 to the first power, which is 2. Okay, so 2, 4, 6, 8, sorry, 2, 4, 8, 16, 32, 64, 128, and we're going to end with 256, okay, which is 2 to the 8th. Okay, that's great. So I've already created a project here in Eclipse called Chapter 2 Demo. And within the source folder, I'm going to ask for a new class. And I'm going to call it Powers of 2 from 2. Okay, because we're not starting at 0, we're starting at 2. And this is going to have a main. These early classes that we're doing are all going to have a main because main is a sort of magically named method that the Java virtual machine looks for when you say you want to run that class. So when it looks at powers of 2 from 2, it looks for main, and if it finds it, it'll run that method. And if it doesn't, it'll say, oh, you asked me to run something that doesn't have a main. So if we want to be able to test these, they all have to have a main. So we're going to click on that checkbox for public static void main and finish. So here's where our code goes. All right. So there are a couple of things to consider here. What I'd like you to be able to do is to model your solution to at least some of the homework assignments after things that you've already seen done. And of course, if you would like to follow along with this, a lot of us think that's a good way to learn. So one of the first things that we talk about within the chapter is we talk about variables. So variables are areas of storage inside the computer program that are usually associated with a name. And in languages like Java, which are highly typed or strongly typed, every variable has a type. And we've already talked about a couple of types. There are number types. There are string types. There are even logical types like the Boolean type that holds true and false. But here, when we're printing out the powers of 2, we have to ask ourselves, what kind of a number type do we want? Do we want one that only holds integers with no fractional parts, or do we want one that holds real numbers, which could have a fractional part? And if we want integers, then the type that we're going to use is int. And if we want to use reals, we're going to use a floating point type called double. And in this case, we're just going to use int because the numbers that we're looking to generate, 2, 4, 8, 16, they're all whole numbers. They're proper ints. So we're going to begin by declaring a variable, int, okay, and let's just call it value. And we're going to say equal to give it an initial value of 2. That's the first thing that we're going to want to print. Okay. Alrighty, that looks good to me. All right, so now we're going to want to use some kind of a loop. in order to print. And the only thing we've learned about within the chapter is a for loop. So let's see how that's going to work. So we can type for, and then we're going to have a control variable, and it's not going to be value. It's going to say int I equals 1. Okay. And we're going to say, because that's going to be 2 to the first power. Okay. And then we're going to say the test, which goes in the middle. So there are 3 parts to this for loop a control expression. So the first is the control variable I, and we declared it new right there in the statement, gave it the initial value of 1. And let's say that we want I to be less than or equal to 8. Okay, so we want to go around the loop as long as I is less than or equal to 8, and when it's higher than that, say 9, well then we're going to want to quit. And the way that we increment a counter control variable for the loop is we use the name of it, and then we typically use the expression plus plus. Okay, so that's the control information for the loop. And let's put curly braces after it. And so we start the curly brace on the same line, put the opening curly brace there. And when we press the enter key, we get not only a new line, but it generates the closing curly brace. So what's going to go on here? Well, okay, we say we want to go through this 8 times, and we're going to print out 8 things, 8 values. When we're done, we're going to print out 2, 4, 8, 16, da, 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 da. Well, I'm the kind of guy who likes to work my way to the solution. I don't have to get everything exactly right in the beginning. In particular, let's just see if I can print 8 lines. Okay, so let's print this. How do we print? System.out.println. Okay, and then in the parens, let's put a string. Let's just say line of output. Okay, well that looks good. So what happens here? Well, we've got one method in the class called main. That means that when we say we want to run this class, this is the code that's going to run. Okay. Within the main, we do an initialization of the variable value to 2, and then we never use it again. So that's just there for when we make this more sophisticated. And then we create a loop, a for loop, that's going to go 8 times, beginning with 1, and it's going to continue to execute the work that's in the body of the loop inside the curly braces. It's going to do that every time until the value of I gets higher than 8, gets up to 9. Okay, so let's give that a run, see what it looks like. So we're going to run as Java application. And I had forgotten to save that, so I saved it. Now it's run. And let's just look down here and see how many of those I got. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I got 8 of them. That's just what I wanted. Okay, well, that's kind of like what I want, all right, but not exactly. One of the things I'd like to do is I'd like to be able to show in each of my outputs that I considered which iteration, which time through the loop I'm on. Okay, so let's do this. Let's say line of output, and let's put a space. And now we're going to have, after that string, I have a space and a plus for concatenation. Okay, and now I'm going to say take the value out of the variable I, which is an int variable, and print that out. Okay, so I should get line of output space 1, line of output space 2, line of output space 3. Okay, well, that's good. That's getting us a little farther along, right? So let's give that a run. Very nice. And again, something we haven't done in this session is if I double click on the console tab, I can see it full screen. And that's great. That's going from 1 to 8. So I'm kind of getting where I would like to go. Okay. All right. So what I really want to do is I want to print out a sequence of numbers, right? So I don't want line of output. Okay. So let's print out just the value I. Okay, so then we're going to get just the number of the line that we're on. Okay, well, that's good. So it's going to be similar to what we have, but not exactly the same. Let's give it a run. Oh, great. So we can see the counting from 1 to 8. Well, that's just about what we want. That's looking good. All right, now we've solved an interesting problem. It's just not the one that we came here to solve, the powers of 2. Now, the other thing is that sometimes we would like to put all of our output on a single line. Why? Well, there's just are times when that's an appropriate way to display them. Okay? So how would we do that? Would we do that with a println, which is a print and a line feed? That's what the len is. Nope, we'll do that with a print. So we learn within the chapter that there is another variation of the print statement. It doesn't say println, it says print. And if we use that, then we're not going to get the carriage returns. We're not going to get the line feeds, whatever you want to call them. Okay, so let's do a save and a run. Well, that looks interesting, but hey, guess what? We don't have anything separating one value from the next. Well, a really easy way to separate them is to separate them with a space. And that's what we do within the chapter. Okay? So how do we do that? Well, we use that concatenation idea again. Okay, so what do we want to print out? Well, we want the value from the variable I, and then we're going to say concatenate plus, and then let's just say double quote, space, double quote, right there. So we're going to get 1 space, 2 space, 3 space, all the way up to 8 space. Well, do we really want a space after 8? Well, the fact is it's invisible, so we don't care. So let's look and see what that looks like. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Well, that looks interesting, doesn't it? So we're printing out these values, right? but they're not really going. We're starting out with 2. I mean, you're starting out with 1, and we really want to start with 2. Well, that's not exactly what we want. Okay, so what could we print out instead of the value that's in I? Well, how about the value that's in value? Okay, yeah, that's good. So I'm just going to go in where I currently have I. I'm just going to type over it and say value. If I could spell, it would say value. All right, that looks good. Okay, well, we're not changing it, so look, I think I'm going to get a bunch of 2s right in a row. Let's see. Yep, a bunch of 2s. Okay, so every time we go through the loop, we print out what's in value, but don't we want to then change the amount that's in value to have it be the proper one for the next time through? And yeah, we can. And here's an interesting way that we do it. If we want to replace the value that's being held in the variable value, well, then we can say value, BS, yeah, value equals is assigned the expression value times 2. I'm sorry. Yeah, times 2. Okay. Now, what's really kind of interesting here is when you look at a statement like that, there are a couple things going on. One is that value always refers to the place in storage with the name value that can hold integer values. But what we're saying is take the expression on the right, what's currently in value, multiply times 2, take that result and then replace it, place the result of that into value. So value will change each time through. It should be multiplied by 2. So let's save this and give it a run. And what have we got? 2, 4, 8, 16, 32, 64, 128, 256. Well, it turns out that those are the powers of 2. 1, 2, 3, 4, 5, 6, 7, and 8. So 2 to the 8th is 256. Okay, we have everything that we want here. All right, and how did we get it? Well, we didn't try to do it all at once, right? I think that's a very important thing to see. First of all, we decided what kind of variable we wanted to use to hold the value that we were going to be printing out, and we decided that was an int. Then we decided, well, for a control structure, we wanted the only kind of loop we've learned about so far, which is the for loop. And we wanted a pretty simple one that would go around 8 times. And so we created the for loop. And then we knew that we wanted to print out 8 pieces of output. And we started out with a very simple output, each one on its own line. And then we went to more sophisticated output. And then we went to more sophisticated output with everything on the same line, but then we had nothing separated the values. Then we went from more sophisticated output with everything on the same line to separated values on the line. And then the very last thing that we did was to add the guts and brains of the operation, which is we came to the realization that after each time we print out the value, we need to do the multiplication to calculate the next value. Now, I just want to point out that this is a little bit wasteful because it actually calculates one more than it actually uses, right? So it prints out it prints out 256, and then it comes through and it multiplies. 256 times 2 gets 512, but then it comes up and it fails the test up here in the for statement, so it never comes through and prints 512. Now there are some people who might say, let's do this in a slightly different way, because we don't want to multiply it one more time when we're not really going to print that. For me, this is the order in which I like to do things, and it seems pretty natural to me that we print out the value that we want, and then we do the work to create the next one. And the fact that we don't actually print out the last one that we calculate, the 512, that's okay. That's maybe a little bit of extra work for the program to do, but certainly reasonable in terms of the efficiency of computer programs compared to how easy they are to read and understand. Okay, so this is a lot like at least one of your homework assignment problems, and I hope you find it inspirational. And we'll just run it one more time for funsies, and there we are. We counted up to 256. So I'm going to say bye until next time.